After understanding the meaning of logarithm and learning all the properties or laws of logarithm, let us solve few questions. The first question says that if log x minus 5 log 3 is equal to negative 2, then find the value of x. So we know the laws of logarithm, where there is a coefficient of any logarithm, then that it changes to the power of the number. So if it is n times log m, it becomes log m raised to n. So that we will apply in this term. We get the first term log x as it is minus log 3 raised to 5, and here negative 2 remains as it is. We know that 3 raised to 5 is 243. So log x minus log 243 is equal to negative 2. Another law of logarithm says that if there are two logarithms in subtraction, log m minus log n, then it becomes log of m divided by n. So applying that rule over here, we get log x divided by 243, that is equals to negative 2. Now when there is no base given in the logarithm, by default the base is common logarithm, that is base is 10. We know the definition of logarithm is derived from indices. If we have a raised to b equals to x, then logarithm is defined as b is equal to log of x to the base a. So in this case we have 10 as a, the bracket x upon 243 is x, and negative 2 is b. So using this definition we get x upon 243 equals to 10 raised to negative 2. So using this definition we get x upon 243 equals to 10 raised to negative 2, which is 1 upon 100. So on cross multiplication, we get x equals to 243 upon 100. That means x is equal to 2.43, and that is the answer for this question. Moving on to the next question, which says find the value of x if log 32 to the base 4 is x minus 4. So using the same definition of logarithm, we can directly convert this into indices form as 32 equals to 4 raised to x minus 4. Now we know that 32 and 4 both are powers of a common base, that is 2. We can write 32 as 2 raised to 5 and 4 as 2 raised to 2. So replacing that value we get 2 raised to 5 equals to 2 raised to 2 whole raised to x minus 4. We have a law for logarithm, law of indices, where if you have a power raised to another power, then both the powers get multiplied. So applying that property over here, we get 2 raised to 5 as it is, and on the right hand side 2 raised to 2x minus 8. 2 getting multiplied with x and 4 both. Now if the bases of left hand side and right hand side of the equations are same, then their powers are also same. Using this property we get 5 equals to 2x minus 8. Now solving this simple linear equation, we get 5 plus 8 equals to 2x, that is 13 equals to 2x. That means x equals to 13 upon 2, which is 6.5, and that is the answer of this question. Our next question says that solve for x. The equation is given and we have to find the value of x. The equation says that log x minus 1 to the base 10 plus log x plus 1 to the base 10 equals to log 1 with the base 2. Here in the same equation we have logarithms with two different bases. The laws of logarithms can be applied only when bases are same. So if we see only the left hand side of the equation, there is a same base 10 and two logarithms are being added. So if logarithms of same base are added, then we have a property where with the same base of logarithm the numbers are multiplied. So using this property we can write log with base 10 x minus 1 times x plus 1, and we know that logarithm of 1 with any base is always 0. So the right hand side of the equation becomes 0. This is the property, this is an identity x plus 1 x minus 1 that becomes difference of two squares, that is log x squared minus 1 to the base 10, and the right hand side is 0. Now using again the definition of logarithm, conversion from logarithmic form to indices form, we get x squared minus 1 equals to 10 raised to 0. That is x squared minus 1 equals to 1. Transposing negative 1 on other side, we get x squared equals to 2, and therefore x is equal to plus or minus root 2. The approximate value of root 2 is 1.4. Now if we put the value of value of x as negative root 2, that is negative 1.4 in this second term, we get negative 1.4 plus 1, that is negative 0.4. Also if we put it in the first term, still we get a negative number in the logarithm which is not defined. So therefore the value of x as negative root 2 is rejected, and the final answer is x is equals to positive root 2. Moving on to the next question, which says that evaluate means find the value of the given logarithmic expression. The given expression is 3 times log 2 minus 1/3 of log 27 plus log 12 minus log 4 plus 3 times log 5. So using the laws of logarithms one by one, we can solve this question The first law that we are going to use here is m times log a becomes log a raised to m. So here we have 1, 2 and 3 coefficients in the 3 different terms. So that will become log 2 raised to 3 minus log 27 raised to 1/3 plus log 12 as it is minus log 4 as it is plus log 5 raised to 3. On simplifying these powers, we get log 2 to the power 3, that is 2 cube, which is 8, minus log cube root of 27, that is 3, plus log 12 minus log 4 plus log 5 cube, that is 125. Now using the addition and subtraction of logarithms property, the logarithms which are being subtracted, their numbers will be divided, and the logarithms which are added, their numbers will be multiplied. So the next step will be a common logarithm with 8 multiplied by 12 multiplied by 125 and divided by 3 multiplied by 4. On simplifying this, we have 3 times 4, which is 12. So 12 and 12 get cancelled. We are left with 8 times 125, which is log 1000. Log 1000 can be written as log of 10 raised to 3. And again in this question we are not given with the base, so by default it is common logarithm, that means the base is 10. So this becomes 3 times log 10 with the base 10, that is 3 times 1. So the answer is 3. So the value of given logarithmic expression is 3. In the next question, which says if logarithm of 4 is 0.6020, then find the value of logarithm of 80. So we have to use the given value of logarithm of 4 and find the value of logarithm of 80. We know one value, that logarithm of 10 with a common base, that is 10, is 1. So first of all we can split 80 as logarithm of 80 as logarithm of 8 times 10, which can be written as logarithm of 8 plus logarithm of 10. So logarithm of 10 is value is 1. And we have to represent 8 with some power of 4. So let's say 8 equals to 4 raised to some power. So 8 can be written as 2 cube and 4 can be written as 2 square to get same base on both the sides. So 2 cube equals to 2 raised to 2x, which gives 3 equals to 2x, or x equals to 3 upon 2. That means 8 can be written as 4 raised to 3 upon 2. So replacing this value, we get logarithm of 4 raised to 3 upon 2 plus 1. Log 10 value is 1. This is equal to 3 by 2 times logarithm of 4 plus 1. And we know the value of logarithm 4 in the given information. So 3 by 2 times 0.6020 plus 1. So 3 by 2 times 0.6020, we can cancel out the denominator 2 with 0.3010, and that is multiplied by 3 to give 0.9010 plus 1. So the final answer is 1.90, sorry, this will be 9030. So the final answer is 1.9030. So the value of log 80 is 1.9030. The next question says that express log of 4.5 in terms of log 2 and log 3. So we have to represent 4.5 with the factors 2 and 3. We know 4.5, that is half of 9, 9 by 2, and 9 is 3 squared. So 4.5 is equal to 3 squared upon 2. So we can write log 4.5 equals to log 3 squared upon 2. So the division of number in logarithm gives the subtraction of two logarithms, that is log 3 squared minus log 2, and the power of a number inside logarithm becomes the coefficient. So 2 times log 3 minus log 2. So we have expressed log 4.5 in terms of log 2 and log 3. So that gives the final answer for this question. The next question is solve for x. The equation given is log of 64 divided by log of 8 gives log of x. So find the value of x for this equation. Whenever we have two logarithms in division, we do not have any law for that. So we have to try and get same numbers in numerator and denominator of the fraction. We know that 64 is a square of 8. So this can be written as log of 8 squared and denominator of log 8 as it is. So this gives 2 times log 8 divided by log 8. And now we have log 8 as a common number, common factor in numerator and denominator, which can be cancelled out. So in the given equation, log 64 upon log 8 equals to log x. Now we are left with 2 is equal to log x. Again, the base of logarithm in this question is 10, and converting this in the indices form, we get x equals to 10 raised to 2. So the final answer here is x equals to 100. The next question says, given that 2 times log x plus 1 is equal to log 250, find the value of x and log 2x. So first of all, the given equation 2 times log x plus 1 is equals to log of 250. Now the base not given means the base of logarithm is 10, and we know that 1 is equal to logarithm of any number with the same base. So here the given base in the equation is 10. So we can write 1 is equals to log 10 with base 10. So So here 2 log x plus 1 is replaced as log 10 gives log 250 as it is. The coefficient of logarithm becomes power of the number. So next step will be log x squared plus log 10 equals to log 250. Two logarithms with addition will be a common logarithm with multiplication of their numbers, that is x squared times 10, again log 250 as it is. So now we are left with logarithm of 10x squared is equal to logarithm of 250. The basis of the logarithm on either side of the equation is same. So we can remove logarithm from both the sides. That is known as taking anti-log on both the sides. So now we are left with 10x squared is equals to 250. That means x squared equals to 25. If x squared equals to 25, x is equals to plus or minus 5. Now if we choose x equals to negative 5, then log of x becomes log of negative 5, which is not defined. Logarithm for negative numbers are not defined. Therefore our final answer will be x equals to only positive 5. So this is the first answer, value of x. In the second answer, we have to find the value of log 2x. So getting the value of x, we can solve the value of log 2x, that is log 2 times 5, which is log 10. So log 10 with the same base, that is 1. So answer for the second question, log 2x is 1. The last question for this video, which says that if log a to the base 2 is 3, log b to the base 3 is 2, and log c to the base 4 is 1, then find the value of 3a plus 2b minus 10c. To start the solution, the first step required is convert the three logarithmic form into indices form so that we get the values of a, b and c. So if log a to the base 2 is 3, then a is equal to 2 raised to 3, that gives a equals to 8. If log b to the base 3 is 2, then b is equals to 3 raised to 2, that gives b equals to 9. And the last one, log c to the base 4 equals to 1, that means c equals to 4 raised to 1, that is the value of c is 4. Now substituting the values of a, b and c in the given expression, which is 3a plus 2b minus 10c, we get 3 times 8 plus 2 times 9 minus 10 times 4, that equals to 24 plus 18 minus 40, and the answer for this 24 plus 18, that gives 42, and then subtract 40, so final answer is 2. So in this video you have seen the application of definition of the logarithm, that is conversion from indices form to the logarithmic form, and the conversion of logarithmic form to indices form. and we have also applied the different properties or laws of logarithm. Thank you for watching the video.